Course name, Advanced Experimental Design. Course code, STAT 504. Time, 3 hours. Total marks, 60. Answer any 5 questions. Marks are indicated at the end of the question. Q1. A. What do you mean by experimental design? Why do you need to study experimental design? 4. B. Define the following terms with example. I. Symmetrical factorial experiment. E. Screening experiment. E. Contrast. IV. Alias. 4. C. What is confounding? Describe the necessity and conditions of confounding. 4. Q2. A. Discuss generalized interactions with example. If two component effects X and Y are completely confounded with blocks in a 5-carat experiment, then XY, XYZ, XY 5-carat, N-1, called generalized interactions are also confounded. 6. B. In a 3 to the power of 4 factorial experiment, ABC squared and ABC squared are to be partially confounded. Give the layout and discuss the method of analysis. 6. Q3. A. What do you mean by fractional replication? Describe the situation where it can be used. 6. B. Write down the merits and demerits of fractional replication. 4. C. Construct 1/2 replicate of 2 to the power of 4 factorial experiment with ABCD as defining contrast. Estimate the factorial effects and find the aliases of the main effects and 2-factor interaction effects of the design. 6. Q4. A. What is an incomplete block design? Explain with examples. Why is such design needed at all? 4. B. Define balanced incomplete block design. Describe the situations which call for the application of this design. 3. C. In a BIBD with usual parameters show that B is greater than or equal to versus 5. Q5. A. Define a split plot design, SPD. Compare and contrast SPD with RBD. 5. B. How does BIBD differ from PBIBD? Show that under usual notation lambda is greater than or equal to V-1, R, K-1. 7. Q6. A. What is orthogonal design? Show that BIBD is not an orthogonal design. 5. B. What is orthogonal Latin square? Construct a BIBD with parameters B equals 20, V equals 16, R equals 5, K equals 4, lambda equals 1. 5. C. Define balanced design and lattice design. 2. Q7. A. What is split plot design and what are the situations which call for this design? 3. B. Discuss the analysis procedure of split plot design. 5. C. Write down the advantages and disadvantages of split plot design. 4. Q8. A. What is response surface methodology? How does it differ from usual design? 4. B. Generate an appropriate model of first-order design. Find the estimates of parameters with their estimated standard errors for such design. 6. C. Define rotatable design. 2.